This example shows a typical workflow for designing molded parts. Molded parts are designed with thin walls to promote thermal cooling in the mold. Because of the thin walls, they also have internal ribs and bosses to provide structural rigidity. You typically create molded parts in 3 phases. First, you create the basic shape as a solid body. Second, you use the shell command to create the thin-walled part. This second phase is the key to molded parts. And in the third phase, you add detailed features to complete the design. Let's look at the drill handle in greater detail. Start phase 1 by establishing 2 key datum coordinate systems. One at the handle base. One locating the drill motor. Next, sketch major shapes on the planes of the datum coordinate systems. Use the extrude, revolve, and sweep commands to create and unite major shapes from the sketches. Create any edge blends with radii larger than the wall thickness of the part in phase 1 of your design. In the second phase, use the shell command to hollow out the part. For this part, set the thickness of 2.5 mm and select the faces to pierce. The result is a thin-walled solid body. In the third phase, add detailed features that either appear only on one side of the thin-walled part or cut through the part. The cooling vents and direction selector cutout are examples of features that cut through the part. These small edge blends and the emboss features appear only on one side of the part. Inside the model, there are numerous bosses and ribs, typical of plastic molded parts. Create them using the Until Next option of the extrude command. When designing a molded part, be sure to plan which features should be created before the shell, and which should be created after. To summarize, you typically design molded parts in 3 phases. First, establish key datums and create the basic shape as a solid body. Second, use the shell command to create the thin-walled part. And third, add detailed features.